about translations. Translations are really just moves or shifts, or sometimes they call them slides, because you're going to take an object, and the object can be like a rectangle or a triangle or even a point, and you're going to move them a certain distance. And one of the things you want to make sure that you know is that a translation is a rigid motion, meaning all of the points on the figure are the exact same distance they were from each other. It's the exact same shape. So if you take a triangle and you do a translation to it, it's just moving that exact same triangle, and everything in the triangle moved the same distance. So that's why they say it's a rigid motion, because the two objects, the pre-image and the image, are congruent figures. Okay, and again, sometimes they call this a slide, a translation, a move, all those things. So let's just do these things. So this is on GeoGebra. You can just Google GeoGebra geometry and go to this, and you can make and play around with this. And so what it allows me to do is that I have 3 points here, E, J, and G, and then I have a vector. So this vector is how this software wants you to do the translation. That's how you type it in. So if you look at this vector, look where it is. So the vector goes over 4 up 2. Okay, it's going to increase all of their x values by 4 and increase all of their y values by 2. So I translate by a vector, and it says select the object and then select the vector. Boom. E prime, so E is the pre-image and E is the image. So this is the start, and this is what happens if you do this translation. It says, hey, take E and boom, boom, do that translation to it. I can do the same thing. I can take J and I can do that translation. It's going to move J to J prime, 4 over and 2 up. I can select G and I can select that, and I can move G prime, 4 over and 2 up. All of these objects were translated by that vector. The vector was add 4 to my x, add 4 to my y. And I think I can even make it into a polygon. So I'm going to take the original E, J, G and turn it into a polygon. And then you can see that if I look at J prime, G prime, and E prime, it's the exact same polygon. So if I move a polygon by translation, it's the same thing as moving all the points. It's the exact same triangle, same lengths, same angles. I just moved it, and I told it to move by that translation. Okay, so let's go to this next one. I'm going to take this vector. This vector says go 4 to the right and 1 down, and I'm going to do it all at one time to this polygon. So I'm going to select the polygon and then select it, and boom. It took every one of the points in the polygon and did this translation, this move. It took this object and it slid it over here. E to E prime, F to F prime, I to I prime. All of them are 4 to the right and 1 down. And again, it's a rigid motion. It's the same shape. In geometry we say it's a congruent shape, of course. Same angles, same side lengths, same ratios, all those good things. Okay? This one, I'm going to take the triangle, and now I'm going to translate it by this vector. This vector would be -1, 5. -1, 5 tells you to move x value over 1 to the left and up 5. So let's go over here to transform. I'm going to translate this object by that vector. And again, look what I did to everything. I just moved it this exact same amount, 1 over and 5 up. And again, it matters obviously that I went to the left. And I think maybe I can actually even just move this point K around. Look at that. If I change the translation vector, I'm just moving where I put that image. So I keep giving it a different. This one, I just moved it straight up 5. Here I moved it to the right 4. Here I moved everything down 3. Here I moved it 5 over and 3 up. I just took every one of its x values and did that too. So a translation is just a move or a slide. Again, I can slide rectangles or triangles. I can slide L-shaped things. And again, I can just do points. And what I showed you is that the point and that were actually the same thing. Okay, and how about this one over here? I give you the pre-image, and then I give you the image. And I say, what is the vector? What is the translation that you did. And you're like, oh, all I have to do is count. Here's G, 1, 2, 3, 3 down, and 1, 2, 3, 4, 5, 6 over. And that's going to be the same for all of them. Go to E, 1, 2, 3, 1, 2, 3, 4, 5, 6. Okay, so the translation there would be -3, comma, 6, comma, -3. 6 over, X first, then Y, just like always. And again, you can do F, 6 over, 3 down. So I could give you the pre-image and the image and ask for the translation, or I could give you the pre-image and the translation, and you have to draw then the new one. Okay, makes sense so far? So translations are, up, down, lefts, and rights. The original image is called the pre-image. The next one is the next image, and you can see it uses prime. So this is G, and then this is G prime. If I did it again, so go down here and translate again. So take this and translate again, then I'm going to get double primes, which just means it's the next step in the process. So I move it here a little bit, kind of see it better. So I went from here to here, and went from here to here, and I keep doing the same translation, and I keep moving. And so actually I can probably even change this now, and again, you're going to change them all. So this is just moving all of them up 2, all of them up 3, all of them up 4 from each other, up 5, over 3, stuff like that. You cool with this? You just got the exact same object. I can go down, I can go to the right, I can do whatever I want. Okay, so we did those, and we did those, and we did those, and and I did that, right? You can do any of those you want. And the last thing is the notation. So let's pull up this document. This is how it looks algebraically in a formula sense. So like right here, this says x comma y, and this isn't supposed to be a nice arrow, x plus 2 comma y minus 5. And it is exactly what you think it should be. It says take any coordinate point and then do what to it? Add 2 to its x value and subtract 5 from its y value. All that does is shift it, take the original object, and go right 2 and down 5. Where this one, x comma y goes to x minus 4 and y plus 7. If you subtract 4 from the x value, you're going to go left 4. And if you add 4 to the y value, you're going to go up 7. Okay, so this is a right 2, down 5. And this is a left 4, up 7. So you're going to see this notation sometimes. But this notation is the exact same as looking at this vector. This vector is 4, 1. So this one would be like x comma y would go to x plus 4, y minus 1. We added 4 to all their y values and to their x values, and we subtracted 1 from their y values. Okay, this is translations. You're going to do a worksheet, of course, and kind of work all those things they talk about. They might use the word map. So what maps the pre-image to the image? And again, they're just talking about the translation. They're talking about the vector that does that. And again, these are rigid translations because the object is exactly the same. Okay, hopefully this helps you get started on translations.